Okay, so we are going to look at what that of the D. Okay, D, what are we giving? Okay, and thankfully the function came in the form that we want. Okay, that is the relation form. So we equally extract it in that form. So this is what we have. Okay. Remember, first step, you have to make the representation. Okay, and it's a capital L. Please, we are starting a new sentence. So we are going to have what? Y to be equal to f of x. So in this case, this implies that y is equal to x squared plus what? 2. Okay, what are we going to do here? We are going to make x the subject as our next step. So fortunately for us, only one term in x, so we are going to isolate. So that's going to give us what? X squared is equal to y, okay, minus 2. Am I clear?
Yes, please.
Good. So now at this point, we know we are going to find x. So what do you think we should do in making x the subject at this point? Any idea?
Please, the square root.
So you take the square root of both sides. Is that not it?
Yes, please.
Okay, so I'm going to have the square root of x squared is equal to the square root of what? Of y minus 2. Is that what you write?
No, please.
Okay, so what would you write then?
Please, the plus or minus sign
Y
before you
plus or
take the
minus? Y plus or minus? Is it by instinct? Or there is a certain one? I said, why are we supposed to introduce plus or minus here? Is it by instinct or there is a reason?
Please, it's please, I think it's because you can have two values of y and you can't restrict it to being only negative or positive. That's why I introduced the plus or minus sign.
Two values of y, but you are looking for x though. So if
Sorry,
the x that you are talking, two values of x.
of x.
Okay, very good. Only that this explanation would have been better. If you look at the x, x is what an object, and your object can be positive or negative. You get it? So that's the more reason why when you are making x the subject here, you introduce plus or minus. Okay, failure to introduce that will be costly. Take note. All right. So at this point, x would be equal to plus or minus root of what? Y minus what? 2. So at this point, we are through with our change of subject. Step 3 now is what we are supposed to look at, which is what? Finding the domain of this function. Okay, so let's see the domain that will coincide with the range of this function. Is there any restriction on this side?
Yes, please.
Okay, so what would be the restriction?
Please, there's a square root and a variable is under the square root.
So how would we proceed? Once you realize that your variable is under a square root, now let's proceed. So for the range, which indirectly is the same as the domain, okay, what would be our condition for us to find the restriction? I'm waiting. You are expert in finding domain. So I'm not expecting you to waste time here. Let's go. Make me proud. And yourself as well.
Y is greater than or equal to 2.
Why? No, I'm talking about what you write first.
Oh, you're going to write x is such that. No, y is such that. Sorry.
No, I'm talking
Y.
about if we are continuing from here. I'm not drawing my conclusion. We need to find
Please,
it.
y minus
Y minus
2
2
greater than or equal to 0.
so it is greater than or equal to 0. So please take note. I think she was drawing the hair conclusion. But okay, at this point, you cannot draw a conclusion. You are matured anyway. You can draw your conclusion from here straight away if it is an objective question. But for subjective, you need to go through this. So in this case, what do? You come here, y must be greater than or equal to, remove this one here, which will be 2. Okay, so now you know your restriction. You go and draw your conclusion. Therefore, the range of which function and the function is f of x, okay, will be equal to, what do we write? Y is such that y belongs to a set of real numbers, all right, but y must be greater than or equal to 2. Then you close your curly bracket. Apa,
Trying.
okay, good, all right. So now this becomes what the solution to, so at this point, anytime you are asked to find the range of functions of this nature, whether the function is a linear function, your function is a rational function, your function is a quadratic function, you should be able to deal with it. Okay, at this point. All right. Okay, and for the quadratic function, one that you can, okay, easily make as a subject, that one will be of this form. There will be only a squared term and a constant term. There shouldn't be any linear term. Immediately there's a linear term, your change of subject will be programmatic. So at your level, usually will give you the quadratic expression. You will get a constant term and a quadratic term. There is no linear term. So please take note. And when you see that, you should smile at the person because you now know how to find the range of functions of that nature. Okay, so at this point, that will be
Mr.
it for,
Hartman,
yes, please.
please, can you go over like the terms you have to know if there's a restriction in the conclusion part?
The term, I don't
Like
really,
for you to know whether there's a restriction or not.
is it, there is a restriction in your, were you with us when you started the domain?
No, please.
Okay, then please, the video was put on the platform. Other than that, it will not be fair to those who were. So you were supposed to watch the video because we started from there. So go and watch the video. I'm there, so I can talk to you, okay, there. And you get the
Yes, please.
concept. When you get it, then you come and relate it with that. Other than that, you take the rest back and it will not be fair. I know it wasn't your fault anyway, that you were not with us. Okay, but
Thank you.
that's why the videos are there, so that, okay, your own convenient time, you watch it to address yourself, okay, of what the situation that you have.
Thank
Okay,
you.
you're welcome. All right. However, okay, I think now we are done. We are going to look at a new concept. So I won't mention the domain or range again. Okay, so now, Kukwa,
Mr.
if you
Hartman,
think okay, you will need more time for you to do these questions, the last, especially this E and F, because it involves the domain, finding the domain. You said you are not conversant, okay, with it. Seek permission, go and watch those videos before you can relate. However, the second one that we are going to see has nothing to do with what the domain or even the range. Okay.
yes,
So
please.
now let's look at the second question. The second question will, okay, move us into another concept. Okay, and that concept is what? Finding the zeros of what as a function. So zeros of a function. Okay, even this one I could have written range of a function, but I made it general. Okay. All right. So zeros of a function. Just as the name suggests, if you're asked to find the zeros of a function, You are asked to find the value or values of x that will make the function 0. If you saw the input that will make the function was 0, as simple as that. So indirectly, this is what we have. The 0 of a function f of x is the value or values of x, which make okay the function. Okay, now I know my function, so let me write f of x, okay, 0. So f of x is the same as y. So take note. So the zeros of a function will be, okay, the value of values of x, which will make or make the function was 0. So if you substitute, you get 0. Okay, so now let's look at the step. It's so easy. I think so far what we've done, okay, this will be the easiest because it will end up with a certain situation that you are very comfortable dealing with no analysis. Okay, so to find the zeros of f of x, okay, this is what you do. Step 1. Okay, let f of x be equal to 0. Then step 2. Okay, solve the resultant equation in step, okay, 1 or in 1. Is my point well made? Hello, is my point well made?
Yes.
Okay, very good. So if that's the case, then I'm going to capture them and start dealing with it. But I think I have space here. So let me see whether we can solve the very first question there. So solution A, and I'm looking at 2A. Okay, so find the zeros of the following. Please take note, the zeros, there is no E. Okay, okay, so take note. All right, so solution, what are we giving A? Giving, okay, f of x is equal to what? 2x minus 1. Okay, so now this is what we are going to write. For the zeros, okay, my f of x should be equal to 0. Remember, we said. So this implies, okay, that what my 2x minus 1 should be equal to 0. And the resultant equation here is a linear equation, which we are all expecting solving. So it means at this point, we will be solving equations. So anytime you equate, you end up getting an equation that you solve. That's all. So you are comfortable working with linear equations and quadratic equations. However, the question involves cubic equations, special ways of factorizing cubic equation. I'll tell you. However, if you can factorize cubic equation and more than cubic equation, then there is a certain topic that you have to be worked through, which is what the polynomial function, but you haven't done that. So I'll give you the special cubic expressions, in your equation that you can easily factorize, at this point, so that, you won't be stuck. So now I write this again. Move this one to the side, 1. Remember, we need to write it again before we divide. Okay, then over 2 over 2. I'm going to conclude here or continue here, I should say. So my x will be equal to what? 1 over 2. So you draw your conclusion. Okay, instead of writing therefore the zeros are, you can just write therefore, x is equal to 1 over 2. So indirectly, you remember when you're asked to find the zeros, you are asked to solve for the variable that your function depends on in that equation. So this means if x is equal to half, your function will be equal to 0, and you can see that it makes sense. If this is half, you are going to get what? 2 into half, the 2 will cancel, you get 1 minus 1, which gives you 1, 0. You get it? So we equally do more of this when we are doing zeros of a polynomial with the same strength. Polynomials will be functions, only the special type of function. So it will be the same concept. Any questions at this point? Okay, so let's look at our next question. Okay, so the question, what do we have? B, what are we giving? We are giving the function is h of x. Okay, in the relation form, we thank God. Okay, so x squared, okay, plus 4x minus what, 5. So the second one, I'm going to deal with it maturely. Okay, so this is how I expect you to deal with yours too. So I will take out some of the steps. So meaning those steps that will be taken out will not be costly if it's left out. Okay, so now this is what you write for, okay, the domain, forgive me, for the zeros. Okay, what do? We set the function to 0. Okay, so straight away you know your function. So just set it to 0. So don't come and write h of x is equal to 0. It's not necessary. The same h of x is this, is equal to 0. So I can write, okay, comma, x squared minus or plus 4x minus 5 is equal to 0. Is my point well made? Hello, is my point well made?
Yes.
Okay, all right. So at this point, this is what we are going to do. If you see this resultant equation, obviously the equation that you are comfortable with, which is a quadratic equation, and we are all masters in solving quadratic equations, irrespective of what the method, you should be fine. So at this point, what did we do? Quadratic equation, but I've told you, of all the methods, the 3 methods, okay, the convenient one is the factorization, though not all equations can be solved by factorization, especially when you realize that this quadratic expression is not factorable. But if it is factorable, always settle on the method of factorization. So let's see. Can I get factors of, so the coefficient is 1, you can't go. So come and concentrate on minus 5. Can I get factors of minus 5? Or yes, factors of 5. When I multiply, I will get minus 5. When I add, I will get what? Positive 4. Any factors of 5? Factor pair.
Minus 1 and 5.
Minus what?
1 and 5.
Minus 1 and positive 5. Very good. So it means we are going to split this one in using these two, okay, factors. So at this point, I'll come and write. This implies that x squared, okay, plus what? 5x minus x, okay, minus 5 is equal to 0. And like I said, okay, you are going to group the first two, the last two, and factorize. Please, and I repeat, and I'm pleading, avoid using bracket to group. Group mentally and factorize. So first two, group mentally and factorize. I'll get x out, x plus 5. Last two, group mentally, I factorize. I'll get minus 1, then get x plus what, 5. And this is equal to 0. Don't use your calculator, please. Okay, to do your factorization straight away. So don't move from this step to the step that, or even from this step to the step that I'm going to write, which is what your x minus 1 into x plus 5 is equal to 0. Okay, so go through all the steps. Solving will involve factorization by grouping. So let us see the grouping. So in this, at this point, you set each factor to 0. So this particular step is equally important. Okay, so x minus 1 is equal to 0, or x plus 5 is equal to 0. And remember, I am repeating once again, when you are disconnecting these two, separating them, you separate them with what? Or. Because it's either this is equal to 0 or this is equal to 0. You cannot ignore the or. You cannot use comma. You cannot use and. The connector is really or. And this is repeated for emphasis because I've been telling you, and I know some of you, you do exactly what you are told not to do. So please be extremely careful. All right, so at this point, we have x is equal to what? 1. So x is equal to -5. Okay, now what do? We are going to have our conclusion drawn. Okay, then I'll write, therefore, okay, x is equal to 1 or -5. Or someone can equally say that, therefore, the zero, or start with it, therefore, x is equal to 1, okay, then -5, okay, are the zeros. Okay, but this one will be long. So it just establishes the same point. So conclude with the first one. That's fine. So zeros, you solve an equation. So take it like you end up solving an equation. And when you are asked to solve an equation, okay, you are asked to find the value or values of the variable involved. As simple as that. Am I clear?
Yes, please.
Okay, so now to the last question. Okay, no, not really, maybe last but one. Okay, I have to do this and this one as well. Okay, so let's see. The next one I think is C. Giving, what are we giving? J of x is equal to 2x squared, okay, minus x all over 3x plus 2. So this time around, unlike the first two functions, where we're dealing with what do you call it? A non-rational function. This time around, we are dealing with a rational function. So the first two were polynomial functions. So this is what you do. Again, you come and write for the zero. Okay, and this is what you do. Anytime, the same concept, you equate this one to 0. So it will be this equals to 0 and you solve. However, anytime you are going to have a rational function, okay, and you are going to, what do you call it, equate it to 0. If that rational function will be 0, then in the numerator that will be 0. So it will be the same as you just equate the numerator to 0. However, okay, I'm going to handle this one, the first one as always, not the matured way for you to get a concept. Then the next one, which will be also a rational one, will handle that one the matured way. So in this case, I will know that my g of x, which is 2x squared minus x over 3x plus 2, should be equal to 0. So at this point, you can see that you cross multiply, and you cross multiply, you end up getting only your numerator function equated to 0. So when you are matured, you know that if you equate this one to 0, or this will be equal to 0, when the numerator is 0, then you go and solve. Because any number a over b is 0 when the numerator a is equal to 0. It's infinity when your denominator b is 0. So take note. So at this point, I'll write, this implies that my numerator 2x squared minus x is equal to 0. So I'll end up getting, I can factor out x here. So I'll get 2x, okay, minus 1 is equal to 0. So at this point, I have, okay, two products of two factors, okay, be giving me 0. So I have to split. Okay, so this means x, okay, is equal to 0, okay, comma, 2x minus 1 is equal to 0. Any issues?
Yes.
Please, the comma.
The comma.
It's supposed to
So
be
you can
all.
correct me. So you have no business not to correct yourself if you do such a mistake. So once you know, then you know the comma here must be on. Really, take note. This x is already solved for, so you come here and solve for your x. So you write 2x is equal to 1, write it again, 2x is equal to 1 over 2 over 2. So in this case, therefore, your zeros will be x is equal to 0, or, okay, x is equal to half. Okay, you can write this the 0, or you can choose not to write the 0 in the same thing. My point well made. Hello, are we all fine?
Yes, please.
Okay, so on this note, okay, this goes, then our last question comes in. Okay. Okay, if you are following, then you are doing well. Keep it up. Okay, so At this point, we move on to the last one, which is E. Okay, E. What are we giving? We are giving the function came in the arrow form, but we extract, okay, in the relation form over 3x, okay, plus 1. So this is what we have. Okay, we are going to deal with this one the matured way. Okay, so what do you write for the 0, comma? Okay, and you know that indirectly you know the first way to deal with it maturely. Equate this function to 0. So don't come and write h of x is equal to what 0 before you come and equate. Just equate straight away. You know that that's the first matured way. Okay, the second matured way, when you have a rational function, instead of equating this one to 0, just equate the numerator to 0. So for the zeros, your numerator s cubed minus x should be equal to 0. Is my point well made?
Yes, please.
You like, you can still write this is equal to, okay, only that the math will be given here, not at that step. All right. Okay, so now at this point, this is what you do. You take equation. Which type of equation is this? Is it linear, quadratic, cubic, quintic?
Cubic.
Cubic. Okay, so it's the same concept. Before you can solve, think of factorization. So this expression here, let's check whether you can factorize. If for nothing at all, you know that, or you can observe that x is here, x is here, so you can factor out x. Remember when I taught you factorization, I said check whether you can factorize a common numerator factor or a common variable factor or both. Here, the common numerator factor is 1. So apart from 1, you cannot, okay, bring anything. Then the next one, variable. The next variable, okay, the variable that we expect is a common variable x. So my next step, I'll get x into x squared minus 1 is equal to 0. Is that clear? Do you agree?
Yes, please.
Okay, but again, unfortunately, you can see that this side, okay, contains 2 factors in which one of them is still factorable. It means your factorization is not yet complete. Even at this point, if you set it to 0, you see that this side that we have here involves a quadratic equation which can be dealt with in a, but always I want to deal with my factorization being complete before I set it to 0. So at this point, I know that x, this, I can use difference of two squares to factor. So that will give you x plus 1, then x minus 1 is equal to 0. So if the product of two numbers gives you 0, and you know that at least one of them should give you 0, by extension, if you have 3 numbers, 4 numbers, at least one of them should be. So you set each of the factors to 0. So I'm going to get x is equal to 0, or x plus 1 is equal to 0, or x minus 1 is equal to 0. So at this point, x is equal to 0 is called for here. You can then solve x is equal to minus 1, x is equal to what? Okay, 1. So at this point, you write therefore x is equal to 0. Okay, you can write comma, x is equal to, sorry, let me write 1 minus 1, or what, or 1. So even here, in the same way, you could have done x is equal to 0 or what, half. And that would be the best way to go, the matured way to draw your conclusion. So, or this, then you are done with what, the solution. All right, so please take note. So if that's the case, then let me see if I can write this one the matured way so that we all follow. So there is a missing step here, which will be your x is equal to half before you can enjoy your conclusion. Therefore, x is equal to 0 or half. Then you draw your conclusion there. So please take note. Are we all fine? Point well made.
Yeah.
Okay, so this will be it, okay, for today. All right, okay, so let me